Hello, my name's Matt. I am the Community and Education Lead for Digital, and welcome to a bumper edition of lesson guidance for coding for climate action, Year 4, data logging unit of work, because in this video we're looking at both lesson 4 and 5. Who'd have thought you could be so lucky? Right, let's have a look then. So you know the website, it's digital.charity, and then go to resources and choose Coding for Climate Action. That will bring you to the page I am on. Scroll down, and then you can choose Year 4 data logging, and that will open up all of the resources uh, for the scheme of work, for what I'm just going to talk about, for your students to be using. Of course, a reminder, you need to take your own copies of these, and anything you distribute to students, of course, they need their own copy as well. But I've said that a few times now. Right, I'm going to need our exemplar data logging journal as well before we get going. Let's dive into lesson 4. So they're related lessons. So we're looking at climate health over these two lessons, and how the our health and can impact on climate, and actually climate can impact on our health as well. So a nice cyclical relationship between health and climate. So quite a cool couple of lessons if you ask me, but let's get into it, and you, I suppose, can be the judge of that. Of course, we've got a nice detailed lesson plan for both of these for you, both of these lessons. So again, I won't go into this in fine detail, but just to remind you that we've got the learning objectives, the lesson snapshot, the link to the national curriculum, as well as any resources you need. And some lesson preparation as well. And you'll notice there that this lesson involves exercise. The students will be doing exercises in this lesson. So just thinking ahead about how you might want to orchestrate that, and what parts of the school or classroom or any preparation you need to do in order to facilitate that is something you'll want to be thinking about. So the start of this lesson, as always now, is to check in on how our broad beans are doing, and that'll be the same for lesson 5 as well. So go and measure broad beans, and have students open up their the data logging journal and mark their broad bean growth for lesson 2, and then for the next lesson for lesson 3 as well. For lesson 5 is week 3. Okay, probably a bit confusing that, but there we go. And as you're aware, that will map the growth of the broad bean as time goes on. Right, so that done, we then move on and think about how climate change and your health might be related. So have some talk and feedback from the students as to what they think might be the relationship between these two things. And I'm assuming, I think maybe you might be assuming as well, the kind of responses you'll be getting are that if there's more pollution, we will be less healthy, right? So the worse we treat the climate, i.e. pollutants, those kind of drivers of climate change, that will also be evident in our health as well. If you live in the city, for example, or in areas that, or a city that's highly polluted anyway, and that's going to impact on your health. And you can see that with political decisions, right? With things like low emission zones in cities like London and Bristol and other places. So there might be some experience of that students have already. So a couple of slides going through that, and kind of showing that exactly that there are impacts on our health as a result of the pollutants from climate change, as well as other things, severe weather, for example, causing injuries. But actually, the drive of the lesson is to turn that on its head, and have students understand that our health has an impact on the climate as well. So in England, the health and care system is responsible for 4 to 5% of the country's carbon footprint. So we really want to drive that home to students, that any kind of roads or any traffic or cars or vehicles on the road, 1 out of 25 to 20 of those vehicles or trips being made has actually got something to do with our health and care system, whether it is me driving to the GPs for an appointment, or an ambulance coming to get somebody, or medical supplies being moved around. All of that, of course, has an impact on the climate, and our health and care system is so amazing and big that it actually has a huge impact on our carbon footprint. For me, that's mind-blowing in and of itself. So the drive of this lesson is to have students, one, understand that, but two, think about, well, that means if we are healthier and fitter, then we can be responsible for lowering the we can all, if we're all healthier and fitter, we can be responsible for lowering the country's carbon footprint, because we will be creating less pressure on the health and care system. Which sets up our data logging fitness activities. Okay, so in order to help monitor our health and fitness, to develop our health and fitness, we can log activity, exercise, monitor our fitness, and use that as a method to drive our decision making about what exercise we need to do, think about our well-being, so on and so forth. So that will be the kind of lessons main thrust now, and the next lessons thrust as well, which I'll talk about in a moment. So students will be looking at star jumps, a program that will monitor star jumps or log star jumps on their microbit, will log skipping and jumping, and if time as well. There is a beep test, and I really want to make this clear. There is a lot here, so I wouldn't, and we tried to make this clear in the lesson plan as well. We wouldn't expect you to necessarily do all three of these, considering the pressures you have on time and the kind of the facilitation this might take. It might be that you can only do one of them, and that's okay. You can still get the idea across with just doing one of these activities. You can still do both lessons, lesson 4 and 5, just doing one of these activities. Hopefully you can do all three, but we understand that you might not be able to. And the other thing to say as well is that, of course, you might have accessibility needs. All of these activities are kind of predicated on students being fully mobile, and there being no accessibility questions around it. And that might not be the case for some students or all of your students or groups of your students. So of course, please, your students and your place of learning best. Please feel free to change any of this, and I'll show you how in a moment, to change any of this so that it meets any accessibility needs. Some ideas might be, for example, instead of star jumps, you can do sitting star jumps, you can do boxercise activities, we can do arm movements and things like that. Or if arms aren't as mobile, we've of course got movement of the legs and things like that. So yeah, please just bear that in mind if it's appropriate for you. So yeah, have students understand that we can be fitter and healthier. That can impact the climate. So let's do some data logging to help us monitor our health and fitness and make some cool decisions about health and fitness. And hopefully have fun as well while we're doing it, right? So of course, we've got to think about the national curriculum and how this relates to computing as well. So what is the input here? Some of the inputs for the microbit. So which of these might be good for detecting when we're doing some sort of activity, for example, a jump or a skip, button A pressed, shaking, or the light level. Well, hopefully students, there's other ones there as well that we could think about, but obviously we're hoping that students will realise that shaking the microbit can detect a movement. So we can build a program around when we get that input. When we get the microbit shaking, then we can have it monitoring the fitness, say, oh, that was a star jump, or that was skipping, or something like that. And sort of a bit more detail on the next slide for you to use with students. And that brings us to the actual program that students will be using, our star jump program. So I'm just going to dive over and open this up so we can see it nice and clearly. Here we go. In fact, I'm going to jump into edit code as well. So just to run through this code, so you have a good understanding of it, we've got two inputs here. We've got on shake, and this is the main kind of driving bit of the program. We've got on button A and B pressed as well, which I'll talk about in a second. And we have not an input, but the startup routine as well. So let's kind of walk through this program. So I'll make sure we all understand it as well as possible. So when the microbit starts, in fact, I might bear with me a second. I might actually put the program onto my microbit, which would have been good to have done before I started filming, but I didn't. So there we go. So when the program starts, when the microbit starts up, it will show a heart icon. And then we have a variable called number of exercises. Okay, variables are beyond the scope of like year 4 curriculum. It's much more the year 6 into year 7 and 8 is when we want students to really be understanding variables, but it's okay to bring it in year 5, I'd say. Year 4, too soon. So we don't need to worry about this variable called number of exercises, but for our understanding, a variable is when a program stores a piece of data so it can be reused, and it gives that data a name. In this case, the name is number of exercises. So at the moment, when we start the program, we see the heart icon appear, and then it doesn't show you anything, but it's created a variable called number of exercises, and that variable is set to 0. So if we ever reuse that variable, it actually, like number of exercises, it actually reuses that number. Okay, whatever number that is. So at the moment that's 0. So when we shake the microbit, it will increase the number of exercises by 1. So instead of being 0, it will be 1. And then if we shake it again, it will set it to 2, and then 3, and then 4, and so on. Okay, and we'll notice each time I do it, we get a little, hopefully each time I shake it, maybe you can't see it, it should clear the screen very quickly and then show the icon again. And you can make that a little bit longer if necessary. In fact, let me talk through this in a bit more of a meaningful way. So when we shake the microbit, let's go through it. We change the number of exercises variable by 1, so we increase the value by 1. Okay, and then we log that number. You see, we can see the variable here, number of exercises. So if it's increased by 1 from 0 to 1, it will log the number 1. The next time I shake it, increases from 1 to 2, so it logs the number 2, and so on and so forth. So we can see how we're logging an increasing number each time we shake the microbit, and it's being logged in a column called skipping. Okay, so when we transfer the data from the microbit to our spreadsheet, we'll have skipping and then the number of exercises there the whole time. Okay, hopefully that makes sense. Now you'll see as well, we've got when button A and B pressed, we can delete the log. Okay, so this is effectively a reset. So we delete the log, get rid of all the data that we've recorded, and set the number of exercises back to 0. Okay, and then we show a nice skull icon, so we know that's actually happened. So that's a way, as if we want to start all over again, rather than having to like re-download a program onto the microbit, we can just press button A and B, and boom, it just moves. We can start afresh. Okay, because turning the microbit on and off won't delete the log, so we need to actually manually do it. Hopefully that makes sense. So if I could just keep shaking this, presumably it is logging all of this. I get no feedback here, so it's with us on purpose, and we could actually amend that so it actually shows the number of exercises as we log. So if I shake this, in fact, we probably want to pause it so it appears. Hopefully that won't flash up too quickly. There we go, we get number 1. We shake it again, we get number 2. We shake it again, number 3. So you can put that code in to actually have it appear on your microbit. We've left it off so students don't know. They'll only find out when they actually go and download the program onto their microbit. Okay, I'll come back in a second to all of that. So we've talked the students through what they think the inputs are, which input importantly detects the star jump, and then maybe got them to understand the delete logs situation. Note that we're not asking questions about what the variable is or how the variables work. We just want to understand the inputs and the outputs here. But of course, if you've got students who are aspirational, they understand like the variable kind of concept, then please do kind of explore that with them. So download the microbits, the program to the microbits. Just 5 done. Do the as many star jumps as possible in 60 seconds, and then log the data into the workbook. So you will remember, hopefully, that to log the data, we plug our microbit back in, and then there will be a pop-up, a folder with a microbit kind of contents in. And it will have you can open a file called My Data, which we can then open up, and you can see that we've got all of these shakes that I've done. Like we see time and skipping. Okay, so I can copy and paste all of those. Those are all my skips, and pop it over into my lesson 4. Well, that would be skipping, not start jump, skipping folder section here. And when you copy and paste that in, this is on view only, so if you want to, students will have their own, they'll have made a copy, or you'll have made a copy for them. When we copy and paste that in, this of course will be blank, you will see a graph populated. And then once we've done that for star jumps and skipping, you can start thinking about trends over time, right? When we've got a steep line or a more of a plateau, what does that mean about the frequency of star jumps or skipping that we're doing? Okay. So once we've put that into our charts, we can then go and use the same program. And in fact, it's the wrong way around on the program I've given you. You've got skipping first and star jump second, so I'll have to change that on the PowerPoint. So you might see the PowerPoint slightly differently. So all we need to do is change this to star jumps. Oops, come back. There we go. And now it will log data under star jumps, which means that we get, we can do exactly the same program, but for each star jump, when we've logged the data, we can pop it into here under star jumps there. You don't actually need to change you don't actually need to change the program at all, technically, but it's quite good practice to, if you want to do that. All it will mean is that when we come to this page here, we'll have the correct title there. So it avoids confusion. It's good practice to be naming things correctly, but I understand you probably have time pressures. So maybe you don't want to rename things and just delete the log and go again. Okay, so once that's done, if you've still got time, then we can move ahead and think about, and of course we've got the same 60 seconds for the skipping or the star jumps and put it into your spreadsheet. So if there's still time, then we can do the beep test. So the beep test is, and I'm sure you know this, but when you run back and forth between 2 points and you try and reach one of the points before a beep happens. And in a proper beep test, the beeps get, the distance between beeps gets shorter and shorter. Okay, the beeping gets faster. You get less time to run back and forth, and the further you can make it through, if the further you can make it through the challenge, the fitter you are. We're not going to put year 4 through something so vigorous. Instead, the microbit will beep every 8 seconds, and you have to shake the microbit when you get to it. And if you shake the microbit, if there are more shakes of the microbit than there are beeps, then you've been running faster than the beeps. If there are less shakes than there are beeps, then you will be running slower than the beeps. So we can measure kind of fitness in relationship to how you are competing against a fixed beeping thing. Okay, so let's have a look at the code for that. If I can open it up, here we go, and get into edit code. So again, a quick run through the program so we have the best understanding of it. So the program, there's no on start routine or anything like that, but the program will forever, so it's going to continually do this, pause for 8 seconds, and then show a heart icon so we can visually see it's beeped, but also make a little beeping noise as well, which you might hear in a second. And you might have heard that through the machine or not, but it happens at the same time as the heart icon. Then we clear the screen and we log the fact that there's been a beep. Okay, a beep has happened. And it's being logged with the value 5. That's a nominal value. We just need a value to say a beep happened, and 1 just seemed a bit too kind of trivial. So 5 is just a nice safe number. Okay. In the meantime, so we set up our microbit, students are running back and forth, okay, and they get back to the microbit. When they get to it, they shake it, whether it's beeped or not, they don't know. Shake it, run back and forth, shake it, run back and forth. So you can decide the distance over which the students are running according to what you think is right. I'd suggest sort of 10, 15 meters, but you might have not space or time for that. Each time the microbit is shaken, has been shaked, it will log that shake in our data column under the word shake. Okay, so we've got 2 values being logged, but two events being logged, a beep and a shake. Okay, and we can see the tick will appear when that has happened. So if somebody's watching, then yeah, that's been shaken, you keep running. Okay, so when we download our data, let me pop that onto the microbit. When we download our data, okay, well, this is quite handy. When this fails, because it does happen, there are other ways to put our program onto a microbit. So it's downloaded as a file, so we can open up our downloads folder, which you won't be able to see this pop up. But that will open up the download folder with the file, the program highlighted. I can drag and drop it into my microbit down on the left-hand side, and it might be that you've seen that happen already. You've done that already, so hopefully that makes sense. So, yes, I know it's failed, but I'm downloading. It's okay. So, if we want to start again and have another go, like working in pairs, for example, and we want to swap over, we can press button A and B, and it will delete all of those logs for us. So hopefully we'll see in a second. There we go. Mine is beeping away every 8 seconds. I've just shaken it, shook it. That's my tick. Fantastic. I'm running fast. Let's get ahead of the beeps. Fantastic. So that one was just fast. I'm gonna get a couple of shakes in there. I want to be faster. So look, I'm running back and forth really super quick. I'm a hero. There we go. So hopefully that makes sense. So I'll come back to that in a second. So the students engage with this activity, they do it, and then we come back to the classroom, and of course we then plug our microbits back into our computers, which I'm doing now, and then we can open up the data program, and there we go. So I've got all of this here, so we can see I've got all of these shakes and less beeps. So I'm running much faster than the 8-second area. So I know I'm nice and fit and healthy. Okay. If we have a look over at the exemplar spreadsheet, what that looks like for this graph is it will show two, or charts, it will show two bars. Okay. Beeps versus shakes. Okay. So what that tells me is if my beep bar is bigger than my shake bar, I've been going slower than I've been running slower than the beeps and vice versa. Okay, so we can use that to track fitness, and of course we can compare it with other people who got the most, who got the least, what's kind of the class average, so on and so forth. Cool. That's the kind of the main bullet points really of lesson 4. Of course, we then get to reflect on what we've done, think about who looked the most, what it tells us about individual and class fitness, and so on. I'm going to turn my beeping microphone off. Can we see any patterns? So kind of a reflection on this, and of course, bringing it back to the idea of this being an activity that helps us reduce carbon emissions. Yeah, so we're fitter, healthier. It means we can walk more, we go to the doctors less, theoretically, you know, and so it has a real hopeful, positive impact on the world around us. Which leads us into lesson 5, okay? Because just doing this as a one-off activity is all well and good, but actually we want to show fitness over time, okay? So if we are getting fitter over time, that's what we want to see. So we've got this idea of, in lesson 1, we learn to use data logging to see what our fitness is there and then. If we do that over multiple instances, if we are data logging, then we can see trends over time, fitness over time. We can use that to make informed decisions. So the second lesson is more of the same, but thinking about what those trends over time tell us and how we can kind of think about decisions we make and so on in the best possible way. So how are our broad beans going? Of course, don't forget the broad beans, put that into your spreadsheet. And then we are going to go through the same 2 activities again. Okay, so students should know what they're doing. I won't talk through all that again. Okay, it's exactly as I've just talked through. But this time, when students enter data, they enter it into their lesson 5. And what that will actually show is a progress score. So if you got more star jumps in lesson 5, you will get a progress score showing how many more. So we can see that this is saying I did 4 more star jumps in lesson 5, and I did 28 more skips in lesson 5 in this lesson, and my progress score for my beeps is 1. So I did 1 more shake than I did in lesson 5. Okay, so we can see what the progress is, what the difference is. Anyway, it might not be progress, but what the difference is between lesson 4 and 5. So we can draw some overall conclusions about, well, what might have caused us to be faster or slower or fitter or not this lesson compared to last lesson. Okay, and then think about how that impacts how we think about exercise, how we engage with exercise. Do we need to do more? Do we need to do less? What are we learning from having done that? So some overall class discussion, thinking about, did they improve? Did they not? Why are they higher or lower compared to last week? What are the trends amongst the class? and then thinking about how that's actually this sort of thing we've made in a microbit. Of course, we're always trying to think about one, the climate, two, our learning, but three, actually these are real things. Often the things that we're teaching in this unit of work are real things that already exist and have been developed, and having students realize actually we're making stuff that exists and it's a real world thing, and I could be making this for a job, like I could be doing this cool stuff and be a part of this cool kind of technology revolution. So yeah, having students understand there are fitness trackers and things like that that are already out there that help people monitor and develop their fitness. And it's not just these things, it's loads of things, Couch to 5K and things like that is another one that springs to mind. Always bringing it back, of course, to the fact that this has a view of thinking about how we are doing this to help ourselves be fitter and healthier, but it's got this kind of peripheral idea of having impact on the environment. Hope that makes sense. Bit of a bumper one, bit rambly, hopefully not too rambly, but thanks again for joining me. And the next video will be the final lesson in the Year 4 unit of work. Hopefully see you there.